Hello everyone, how are you all? I hope सब अच्छे होंगे. So today I am back again with a video on matrices and determinant. So from today onwards I am going to again start with the topic of matrices, and the most important part of the matrices will be start from this particular portion. You can sense the importance of this particular portion that I am going to cover in today's lecture and the upcoming lectures to come soon. We will be talking about basically adjoint, inverse and the different important portion of matrix syllabus. So if you check about the JEE main and advanced question, you will find that most number of questions are actually framed from this particular portion of this lecture. Okay, so आज का lecture काफ़ी important होने वाला है, अच्छा से lecture को follow कीजिएगा. Okay, and this is basically about me. If you are knowing me, then well and good. If not, just read this particular slide. Okay, now let us move forward and see what is today's goal. So today we are basically study about adjoint of matrix, and after we have studied with the adjoint of matrix, we are going to move on the properties of matrix, and then we are going to study about some questions, and then we move on to the inverse of matrix and its properties and questions. So basically this is going to be a very important lecture, keeping in mind the rest portion of the matrix is concerned. Okay, so let us study about adjoint of matrix. Now why do we need adjoint of matrix? Okay, basically this adjoint and the concept of adjoint of matrix is basically developed from the idea when we need to calculate the inverse of matrix. So for example, if we need to calculate a square matrix is given for a given square matrix, okay, now let this square matrix be A. Now if we write something like this for a given square matrix, if I take this matrix over here and I multiply some matrix which is not known to me such that the result is identity matrix, then this such matrix is known as actually A inverse. Okay, this particular matrix is known as inverse of matrix. Now for developing this concept of inverse, we actually need some operator to find the value of inverse, and such thing that we develop is basically known as the adjoint of matrix. Okay, so we're going to be basically seeing what is adjoint and what does adjoint implies. Okay, what is adjoint and what does adjoint implies. Okay, so let us see. So for example, the square determinant, the squared matrix of which is of order n cross n be given by the elements which is a I j such that this is an order of n cross n. Now what we do, instead of taking these elements a I j, we replace all the elements of this particular matrix with the corresponding cofactor. So if I say if c I j is its corresponding cofactors okay of Aij of this particular square matrix A, then such matrix, उस matrix को लेने के बाद if we take the transpose of this particular matrix, then we end up getting the result which is nothing but adjoint of matrix A, So adjoint is particularly defined in this particular fashion. Okay, so here Cij actually denotes the cofactor. Now before moving further in the topic of determinant, I have already discussed an important concept that if determinant of A is given as delta and we replace all the elements of this determinant with the cofactor or the corresponding cofactor, then we end up getting the determinant value of that particular newly formed matrix will be value as delta to the power n minus 1. Now similarly the concept comes from here that, and while we will be studying about the properties, we will see an important property based on this particular thing. Okay, now let us move further and actually see from where actually the idea of inverse is actually taken from. Now if I actually say how to calculate this particular thing, you already might be familiar. So for example, if I take a 2 cross 2 determinant, okay, 2 cross 2 matrix, okay, for example these elements are A, these are B, this is C and D. So if I say make this matrix and change all the elements with its cofactors, so if I say you to calculate the adjoint, what you will basically do, you will basically take these particular elements and calculate its cofactors, and simultaneously after you are done forming the cofactor matrix, you will take a transpose. Okay, so let us try to check on that. Okay, now if I try to check on that, I see of this particular element, if I calculate the cofactor, now if I delete this part first row and the second one, then I calculate the minor, this is D, and minus 1 to the power I plus j, that is positive only, and so we will get this particular element as D over here. And if I calculate the minor for cofactor for this particular element, I will get as C, this is minus of C, and simultaneously if I calculate the cofactor for this particular element, I will get nothing but this I is equal to 1 and j is equal to 1, so I will get again positive of B, and from here I will get this particular element, that is a cancel, and I will get A, and this particular element will have A and sorry over here minus of B. Okay, this element for we are calculating for C, so this is I is equal to 2 and J is equal to 1, so we will get minus of A over here. Now if we take the transpose of this particular matrix, then we actually end up getting the result which is actually the adjoint of matrix A. Okay, so the adjoint can be written as some like this. If we take this transpose, the diagonal elements remain unchanged, and what I see, this particular element remains this. So this is basically the adjoint of a 2 cross 2 matrix. So what I see over here, if I calculate the adjoint of a 2 cross 2 matrix, a 2 cross 2 matrix is given, and I am supposed to calculate the adjoint of this particular matrix. So what I see, so while calculating the adjoint, so what I get, I see that I replace this diagonal element, I replace the diagonal elements with its position. So in spite of A I write D, and in spite of D I write A, and what I do is of these non-diagonal elements I use a negative sign to that, I add a negative to that, and this is how I get the adjoint of particular matrix A, which is a 2 cross 2 matrix. So this is a result. So you can directly remember it as a short trick. Okay, you can directly remember this as a short trick. Okay, short trick to calculate the adjoint of a 2 cross 2 matrix. Now similarly, there will be a short trick to actually calculate the 3 cross 3 matrix. Okay, for a 3 cross 3 matrix. Now let us check on how to calculate for a 3 cross 3 matrix. Okay, now if I go on and talk about 3 cross 3 matrix, so for example, we already are familiar when we were calculating the determinant value of a 3 cross 3 matrix, we are actually doing something which is calculating for 3 cross 3 matrix. Okay, the determinant of 3 cross 3. Now I will teach you a shortcut, and which is similar to the shortcut that I actually were taking up while talking upon the discussion of determinants. So for example, these particular elements are given in this particular fashion. So what you need to do, जब हम लोग डिटरमिनेंट निकाल रहे थे ना, तो हम लोग क्या कर रहे थे, जो दो पहला जो कॉलम है ना उसको एक्सटेंड कर रहे थे. We were extending the first two columns. Okay, so we were extending the first two columns. Now similar to extending first two columns, let us also extend the first two rows. अगर first two rows को फिर से extend कर देते हैं ना, and let us delete the first row and first column, then I end up, and if I calculate these minors, okay, if I calculate these minors and I interchange the position and I write this and this in a form of matrix, if I calculate the minors and I write this form of matrix and taking its transpose, then what I can write over here, this particular minor को क्या लिख सकते हैं, that is EI minus F into H. This particular minor, if I calculate and I write the element over here in this position, because I am taking the, after all I am taking the this minus I am calculating for its individual position, and then I am taking the transpose. Okay, so this particular position will be FG minus of DI, and similarly again I calculate this minor and I write over here, this element is 1 cross 3 position element, so I change this 1 cross 3 position element as 3 cross 1 element, and I write this particular position over here, that is D into H minus E into G, and so on. If I fill all the elements, then I end up getting the result which is known as the adjoint of matrix A. So if this is matrix A, then I end up by doing this particular short transformation, or this is a short trick to get the adjoint of a particular matrix of a square matrix of order 3 cross 3. अब 3 cross 3 से ज़्यादा order पूछेगा नहीं एग्जाम में, so you can directly remember this particular two results very handy. Okay, this particular two results come very handy for calculation purpose. Okay, so let us move further and study about the properties of the adjoint. Okay, which is the most important thing, properties of adjoint. Now these are the most important thing. Okay, adjoint of matrix, properties of adjoint of matrix. Okay, now very fast and the most important property from where actually the concept of inverse is actually calculated is the king property. And this property, if you see, then if you multiply A with the adjoint of this particular matrix A, then you end up getting the result as determinant of A into identity matrix of order n, where n is its order, where n is the order of the matrix. Okay, now this is the most important theorem. Now if I actually see the justification of this theorem, let us use that particular 2 cross 2 matrix that I used, A, B, C and D over here, and if I multiply with adjoint of A, that is basically given as d a over here minus b and minus c over here. What I see, if I multiply these particular things, what I will get? I will get if a is multiplied with d, so ad minus of bc. Similarly, over here also it will be 0, and here it will be 0, and here it will be ad minus bc. So what I see, this ad minus bc is nothing but the determinant value of this particular 2 cross 2 determinant matrix. So I can write this as determinant of A into identity matrix of order 2, because it's a 2 cross 2 matrix. Okay, so I hope this particular result is clear. Okay, and this is the most important result in adjoint of matrix, because based on this particular matrix the following properties of matrix are actually derived. Okay, so I hope this particular jo property tha na, I guess this was clear. Okay, now let us move further and study about the other properties of determinant, like how to calculate the determinant of an adjoint. Okay, now the next important property comes from this particular result that I have already talked about, that is the determinant of adjoint of A, and is basically equal to determinant of A की power n minus 1. Now this particular property I have already talked about while I was discussing about determinant. Now in this particular thing, if you see, if I change this जो determinant of A दे रखा है, अगर डेल्टा है, अगर उस एलिमेंट्स को चेंज करके कोफैक्टर से रिप्लेस कर दिया जाए तो उसका डिटरमिनेंट का वैल्यू क्या होने वाला है, डेल्टा की पावर n minus 1. And similarly, if I take transpose, the determinant value doesn't get changes. Okay, we know that determinant of A and determinant of transpose of A is same. So similarly, this result can be obtained. Let us see the third result, and the third result says something like this: if I take the adjoint of some scalar times of A, and if this particular is actually calculated, then this is k की power minus 1 into adjoint of A. Okay, now let us move to the fourth property, that is actually talks about the adjoint of A. Now this particular thing, if you calculate and see from here in this particular relation, if you see from here, you will get determinant of A की power n minus 2 into matrix A. Okay, so this result also you can derive from this particular king property. Okay, now let's move further and study the most important theorem. इसके ऊपर स्टार मार्क्स लगा रहा हूँ, इसका मतलब सबसे ज़्यादा इंपॉर्टेंट और क्वेश्चन में अगर पूछेगा एडजॉइंट का तो यहाँ से क्वेश्चन पूछने वाला है. ठीक है, सो लेट अस स्टडी. अगर मैं एडजॉइंट ऑफ एंड सो ऑन, आई गो ऑन कैलकुलेटिंग द एडजॉइंट ऑफ डिटर्मिनेंट A matrix A, and finally I take the determinants. Okay, and finally I take the determinant, and if this is repeated k number of times, then इसका जो वैल्यू आता है ना, that is basically determinant of A की पावर n minus 1 whole की पावर k. I hope this particular relation will be clear. Okay, and ये सबसे ज़्यादा important है. I am marking many stars because question में सबसे ज़्यादा इसी से क्वेश्चन पूछता है. Okay, and there will be a question also कि आप गलती कर पे आपको पता है, आपके पास determinant of some constant times of some scalar number, this is scalar, okay, into some matrix दे रखा होगा, and you have to find basically determinant of this, and you will end up, अब तो आप क्या करते हो पता है, डायरेक्टली के बाहर लेकर के ऐसे कर देते हो. तो दिस इज वेरी रॉन्ग. आपको इसकी पावर n तो लिखना चाहिए. यू शुड नॉट फॉरगेट दिस पर्टिकुलर टर्म. सो दिस वेरी इंपॉर्टेंट. अगेन एंड अगेन आई एम रिपीटिंग दिस पर्टिकुलर थिंग. गलती होता है यहाँ से. ओके, गलती यहीं से होता है. I hope you won't make this particular mistake after saying many number of times. Okay, now let us study about the eighth property, that is if you take adjoint of identity matrix, that will be basically equal to identity matrix. Okay, and if you take adjoint of A and his transpose is basically equal to taking transpose of A का adjoint. Okay, now another ninth property is known as the reversal law. Okay, I'm sorry for the spelling. Now this law also was seen in time while we were calculating transpose. Like if I calculate adjoint of A into B, now this is basically equal to adjoint of B multiplied by adjoint of A. Okay, now another important and the property, इसके बेसिस में JEE एडवांस में 2019 में क्वेश्चन आया था, that is if you actually calculate the adjoint of A inverse, and which is also equal to adjoint of A का whole का inverse, and this particular thing is equal to matrix A divided by determinant of A. Now this particular derivation I will take up while I will be talking about inverse of a matrix. Okay, and this question I will also discuss in the while we will be discussing the previous year questions. Okay, let us move further and study how to like find operations and perform the questions of this adjoint questions. Okay, now in the adjoint question, okay, now there will be some questions based on this properties. Okay, now before starting our property, I want to making it very clear. Okay, there may be like in this question. Okay, now let's start with this question only. Okay, to just get a good understanding. For example, whenever we actually have to calculate the adjoint का question में ना directly आपको direct adjoint निकालने नहीं बोलेगा. Okay, now there will be some matrix दे रखा है and then we are also given with another adjoint of matrix and इसका कुछ corresponding element नहीं दे रखा होगा. Okay, now let me take that particular example only. Okay, so for example, now if there matrix A is given, अगर matrix A दे रखा है, for example matrix is given as A, B, C and D and you are also provided with a adjoint of matrix A. Okay, and this particular adjoint is also provided. We know the adjoint whatever it is, but the adjoint has provided with something quantity. Now there will be some variable terms over here. Now in case of 2 cross 2 matrix it is easy to calculate the adjoint, but in case of 3 cross 3 matrix this questions will come. Okay, and they will be giving you some unknown quantity over here in the case of adjoint of A, and you have to calculate this unknown quantity with respect to this. Now in this particular fashion of question you can do one thing, you can take actually, if there the constant occurs one time, you can do one thing. If you take the determinant of this particular thing will be equal to determinant of a ki power n minus 1. Now from here you can also get the value of alpha. Again you can do one more thing, that is alpha comes from the element which corresponds to this particular element. इसका कोफैक्टर से बना के अल्फा आया होगा. अल्फा क्या है बेसिकली, एडजॉइंट क्या है, इट इज बेसिकली द कोफैक्टर मैट्रिक्स का एडजॉइंट ट्रांसपोज. ठीक है, कोफैक्टर वाला जो मैट्रिक्स है उसका ट्रांसपोज लेने पर आया, तो अल्फा अगर आया होगा किसका कोफैक्टर से आया होगा, ए का कोफैक्टर से आया होगा. ऑब्वियसली ए का सॉरी this is a diagonal element, I am very sorry. Okay, let us talk about any non-diagonal element so that I can able to provide my words. Okay, now this is बीटा. अगर मैं बीटा का बात करूँ कहाँ से आया होगा, तो आप क्या बोलोगे, तो बीटा का जो वैल्यू है दैट इज कोफैक्टर वैल्यू, पर किसका कोफैक्टर वैल्यू से आया होगा, ऑफ कोर्स इस बी का कोफैक्टर वैल्यू से आया होगा. दिस इज अगर 2 क्रॉस 1 वाला एलिमेंट पोजीशन एलिमेंट है तो ये आया होगा 1 क्रॉस 2 वाला पोजीशन का एलिमेंट से. ओके, सो आई होप आई एम एबल टू प्रोड्यूस माई वर्ड्स. ठीक है, इन स्पाइट ऑफ सॉल्विंग द डिटर्मिनेंट वैल्यू आप डायरेक्टली इस पर्टिकुलर मेथड से भी कर सकते हो कि ये वैल्यू कहाँ से आया होगा, किस पर्टिकुलर एलिमेंट के कॉरस्पॉन्डिंग से कोफैक्टर से आया होगा, उस पर्टिकुलर कोफैक्टर को कैलकुलेट करके उससे इक्वेट करके आप इस वेरिएबल का वैल्यू ले सकते हैं. ठीक है, सो आई होप दिस पर्टिकुलर थिंग इज क्लियर. ओके, नाउ लेट अस मूव फर्दर एंड सॉल्व दिस पर्टिकुलर क्वेश्चन. So in this question what we see, we are provided with the determinant value of A. We are provided with the determinant value of A. Now why we are provided with the determinant value of A, we are actually have to calculate this alpha from here. Now let us solve this determinant. Okay, now if we see the determinant 1 alpha 1, I hope the determinant calculation is now very easy for you all. Okay, and this particular determinant is given as 2. Now if I try to solve this determinant using some eliminated row transformations, so what I see from here, I can do one thing, I can use column 2 में, अगर मैं कॉलम 2 से कॉलम 1 को सब्ट्रैक्ट करता हूँ एंड कॉलम 3 माइनस 2 टाइम्स ऑफ कॉलम 1 को सब्ट्रैक्ट करता हूँ, देन आई गेट इन द थर्ड रो आई गेट जीरोस, आई गेट 0 over here, I get 0 over here, and similarly this will be 1, this will be 1, and this will be 3 minus alpha, and this will be 1 minus 2 alpha, which value is 2. Now let us solve this thing along this particular third row. Okay, if I solve this along the third row, okay, and if I expand along the third row, okay, so what I will get the value as 1 minus 2 alpha multiplied by 1 minus 3 minus alpha, and this particular value will be equal to not 0, it will be equal to 2. So if I equate it the value to 2, and if I solve this, so this will be 1 minus 3, that is minus 2, and this will be minus 2 alpha plus alpha, that is minus of alpha, is equal to 2. And if I take this 2 over this particular side, then alpha का value क्या आने वाला है, that is minus of 4. So alpha value is minus 4. Okay, now again another relation to get the value of n, we are given out with this particular determinant value, that is 2 into adjoint of 2 times of adjoint of 2 times of A. Okay, now if I solve this, and this is given as 32 की power n, 32 की power n को कैसे लिख सकते हैं, 2 की power 5n. ना इफ आई सॉल्व दिस विल बी 2 की पावर, और इसका ऑर्डर क्या है, दिस इज 3 क्रॉस 3 का मैट्रिक्स है तो 3 आ जाएगा 2 की पावर 3 इंटू एडजॉइंट ऑफ एडजॉइंट ऑफ। अब एडजॉइंट ऑफ इस पर्टिकुलर थिंग का कैसे लिख सकते हैं, इसको ऐसे भी लिख सकते हैं, वी ऑलरेडी नो कि एडजॉइंट ऑफ ए इसका होल डिटर्मिनेंट इज बेसिकली इक्वल टू ए का डिटर्मिनेंट की पावर n-1। ओके, ना इफ आई यूज दिस पर्टिकुलर प्रॉपर्टी, this property, the adjoint of a का determinant का value is equal to determinant of a की power n-1, then I can write it as 2 times of adjoint of 2a का determinant की power 2, and this is given as 2 की power 5n. Now again I can write this as 2 की power 3 into 2 की power 3 into 2, that is 2 की power 6, because यहाँ से जब बाहर निकलेगा ना तो 2 की power 3 होने वाला है and simultaneously स्क्वायर है। ओके, तो 2 की पावर 6 हो जाएगा वाला, एंड देन इफ आई कैलकुलेट डिटर्मिनेंट ऑफ एडजॉइंट ऑफ 2a, दैट्स बेसिकली एडजॉइंट ऑफ डिटर्मिनेंट ऑफ 2 टाइम्स ऑफ a की पावर 2, एंड 2 ऑलरेडी है तो दैट इज 4, तो दिस विल बी 2 की पावर 5n। आई होप द कैलकुलेशन का आपको समझ में आ रहा होगा। सो इफ आई कैलकुलेट दिस विल बी 2 की पावर 3 एंड दिस इज 2 की पावर 6, दिस इज 2 की पावर 9 into, and if I take 2 common from here, this is 2 की पावर 3 and की पावर 4, that is 2 की पावर 12 into a की पावर 4, and a की पावर 4 is determinant of a की पावर 4 basically 2 की पावर 4, and this is equal to 2 की power 5n, and from here if I see this is 2 की power 16 plus 9, that is 2 की power 25 is basically equal to 2 की power 5n, so from here I will get the value of n as 5. Now if I solve this thing and the given question asks me to solve the 3n plus alpha का value कितना होने वाला, I hope ये वाला part दिख रहा होगा, visible है। Okay, if not then I am writing over here, that is 2 की power 25 is basically equal to 2 की power 5n. From here I get the value of n as basically equal to 5. Now 3 into 5 is basically 15, 15 minus 4 is basically equal to 11. From here I can see the option number A is basically the correct answer. Option number A is basically the correct answer to this particular question. Okay, I hope this particular question is clear and how important these questions are in the JEE examination place also. This question actually takes your patience. Okay, if you are patiently solving these questions line step by steps and you don't miss out any particular step, then you won't get the wrong result. I hope this is clear. Okay, now let us solve another question, similar question on this particular properties of determinant. Okay, now in this question it is given out that there is a square matrix which is of order m cross m and इसका जो डिटर्मिनेंट का वैल्यू है ना वो दे रखा है m-n, ठीक है, और m और n एक पर्टिकुलर दो रिलेशन फॉलो कर रहा है, दैट इज 4 टाइम्स ऑफ m प्लस n इज इक्वल टू 22 एंड 17 टाइम्स ऑफ m प्लस 4 टाइम्स ऑफ n इज बेसिकली इक्वल टू 93. Now if I calculate and solve the result for m and n, what I get? Now if I multiply this first relation by 4, I can multiply this first relation by 4, so and then I subtract it, the 4 and 4 cancels, and 17m minus 16 that is m, and 93 minus 88 basically equal to 5. So from here I get the order of the matrix is basically of order 5 cross 5 and इसका जो determinant value है that is equal to 5 minus n, and n का value अगर calculate करेंगे in the first equation that is 20 plus n is equal to 22. From here I get the value of n as 2. ना यहाँ से हम क्या लिख सकते हैं, the determinant value कितना है 3. Okay, so I have this particular thing clear. Okay, now the question asks me to calculate the determinant value of n into adjoint of m times of a. Okay, and this particular value is equal to something 3 की power a, 5 की power b and 6 की power c. Now the question 6 की power c, this is not a prime number, but यहाँ पर क्वेश्चन में गलती करने का चांसेस हो सकता है, दैट्स वाई द क्वेश्चनर जो एग्जामिनर है ना, जो क्वेश्चन बना रहा है, he is making these questions or he or she is making this particular question in such a fashion that आप गलती करके आओगे, आप पता है प्राइम फैक्टर के टर्म में आप लिख दोगे आंसर को and then you will calculate the summation and you get the wrong result. Okay, so I hope this particular thing you will take care of. Okay, then let us calculate this particular determinant using the property. Okay, if I calculate the determinant using the property, what I see, पहले तो n की पावर बाहर आने वाला डिटर्मिनेंट है, अगर n बाहर आएगा that is 2 की पावर कितना बाहर हो गया, is 5 because ऑर्डर कितना है 5. Order this matrix is how much 5. So यहाँ पर क्या आने वाला है, because this product will be obviously of 5 cross 5, so 2 की पावर 5 आने वाला है बाहर. And then if I see the adjoint into adjoint of m of a, then this can be written as m का वैल्यू 5 है तो 5a का डिटर्मिनेंट की पावर n-1 and this n-1 is 4 and 4 की पावर 4 की स्क्वायर 2 because 2 times adjoint repeated. So this particular value is equal to 3 की पावर a, 5 की पावर b and 6 की पावर c. Now from here if I solve this result, what I will get 2 की पावर 5 and if I solve this is 5 की पावर 5 तो बाहर आने वाला है and then again 16 is there, so 5 into 16 that is basically 80 and into 3 की पावर 16, So from here I can see this and write in form of 3, 5 and 6. Then I will get 3 की power 11, 5 की power 80 and 6 की power 5. 2 की पावर 5 और 3 की पावर 5 यहाँ से क्लब करके 6 की पावर 5 लिख सकते हैं. सो फ्रॉम हियर व्हाट आई सी, ए का वैल्यू 11 है एंड बी का वैल्यू कितना है 80 एंड सी का वैल्यू कितना है, दिस इज 5. सो इफ आई कंप्यूट दिस समेशन दैट इज a plus b plus c is basically how much. Now a plus b plus c is basically how much, that is 80 plus 11 plus 5, that is basically 96. So the answer to this particular question will basically 96. और इन ऐसा टाइप का क्वेश्चन जेई में भी आया है, ठीक है, ये जेई का क्वेश्चन ही है बेसिकली. ओके, सो विद दिस आई होप द एडजॉइंट का जो कॉन्सेप्ट है ना, जो प्रॉपर्टीज के ऊपर क्वेश्चन आता है, आई होप दिस पर्टिकुलर थिंग इज क्लियर एंड यू विल नॉट मेक मेनी मिस्टेक्स इन दिस पर्टिकुलर क्वेश्चन. आई होप यू विल रिमेंबर माई वर्ड्स टू. ओके, नाउ लेट अस मूव फर्दर एंड स्टडी अबाउट द इनवर्स ऑफ अ मैट्रिक्स. अब जब पढ़ लिए एडजॉइंट का बारे में पढ़ लिए, तो आवर नेक्स्ट टास्क इज स्टडी अबाउट द इनवर्स ऑफ अ मैट्रिक्स. नाउ बिफोर स्टडीइंग अबाउट द इनवर्स ऑफ अ मैट्रिक्स, आई गोना मेक वन मोर इंपॉर्टेंट थिंग क्लियर. ठीक है, नाउ लेट अस टॉक ऑफ माय वर्ड. Okay, now for example there is a matrix which is of order 2 cross 3, okay, sorry, maybe of order 2 cross 3, and there is another matrix of order, now whenever we are of order 3 cross 2, okay, now whenever we talk about inverse of a matrix, we actually say there is a square there is a matrix. Okay, now if it is explained in terms that there is a matrix and if you are multiplying some another matrix such that the result is identity matrix, we can say this particular matrix will be. And I want to explain this thing is that if I take this matrix A which is of order 2 cross 3 and B which is of order 3 cross 2, and if I multiply this particular two matrix which will be order 2 cross 2, and this matrix can be equal to identity matrix. So can I say that A का inverse B है? Can I say like that? No, I can't say like that. So यहाँ आता है catch. So we have to actually define the concept in very wonderful and good way. Okay, जब भी मैं बताऊँगा ना inverse के बारे में, then I have to write this particular two things very clearly and nicely, that the particular जो matrix लिखने वाला हो that should be a square matrix. तो मैं अगर define करूँ ना, if A is non-singular, okay, non-singular matrix of order n, okay, then we say, and this particular thing is very clear, if agar A non-singular then only we can calculate the determinant inverse of our matrix. Okay, because I will say it in the upcoming thing only. Then okay, let me write it. And if A is a non-singular matrix of order n, and then if n is, then we say A is invertible. That means A का inverse जो value है उसको निकाल सकते हैं. Then we say A is invertible, and there exist a square matrix. Let us name it and named as A inverse. Then there exists a square matrix named as A inverse, okay, of same order such that, okay, such that का symbol ये नहीं होता है, such that, okay, now such that we'll write this, such that A into A inverse is basically equal to identity matrix. Now this definition is actually clear, and from here we can say that this is the inverse of this particular matrix, that is A. फिर से मैं एक्सप्लेन कर रहा हूँ कि अगर A मैट्रिक्स अगर नॉन सिंगुलर हो, अगर जो मैट्रिक्स दे रखा है दैट इज नॉन सिंगुलर है, दैट मीन्स इट मस्ट बी अ स्क्वायर मैट्रिक्स. एंड अगर नॉन सिंगुलर है ऑफ ऑर्डर n, देन वी से दैट A is invertible and there exists a matrix which is named as A inverse such that of same order such that A into A inverse is equal to identity matrix. I hope this particular definition is very clear. Now from this particular relation, now we already studied a important property, that is A into adjoint of A is basically equal to determinant of A into identity matrix of order n. Now from here what I do, I pre-multiply both the side by A inverse. If I multiply both the side by A inverse, I can write this relation as this particular A into A inverse, or from here I will also write A inverse into A is also equal to identity matrix. So from here I can write it as A inverse into A is basically identity matrix into adjoint of A is equal to, this will be basically equal to determinant of A into A inverse. Now from here I can say that A inverse can be related as adjoint of A, adjoint of determinant matrix A divided by determinant of A, adjoint of A divided by determinant of A. From here we can actually derive to the result that A inverse is actually defined in terms of adjoint of A divided by determinant of A. Okay. Now this is the most important definition that I am actually going to use in while talking about inverse. Now आप अगर CBSE बोर्ड्स का जो प्रिपरेशन कर रहे होगे ना, तो वहाँ पर एक थ्योरम आता है that is known as elementary row transformation or elementary operation of matrix, and the question will be there, elementary operation of matrix, and some question will be there to compute the inverse of a matrix, inverse of a square matrix A using the elementary transformation. Okay, now before doing such thing, what you actually need to do, now let us, in order to do such elementary operation to calculate the inverse, we will do for example the elementary operation is same as those things which we actually applied in while we were studying about determinant. Those things, for example, if a matrix A is given and we actually take this particular matrix as form as I dash A, and if I represent, for example, the matrix is given over here. Now let us take an example and try to find out. For example, the matrix is given as 3 minus 1 2 and 2 0 and minus 1, and then we have 3 minus 5 and 0 over here. Okay. Now if I say you to use elementary row transformation and find me the inverse of this particular matrix, then what you will do, you will write this matrix over here, and corresponding to that you will write 1 0 identity matrix of order, the same order over here. And while what your goal should be, आपका goal क्या होना चाहिए, you should try to apply all such elementary operation, such that this A can be reduced to identity matrix. इस A को कुछ भी करो और identity matrix में लेके जाओ, कुछ भी element transformation लगाओ such that A को transform करके identity matrix लेके जाओ. अगर in doing so while taking A to identity matrix, what you end up, जो similar steps आप करते जा रहे हो ना A के ऊपर लगाने से, then the same steps you go on applying in this particular identity matrix. The same steps you go on applying in this particular identity matrix. In that case, what you will see, ना जब आप same step ये identity matrix में देखोगे ना, तो this particular matrix जो identity matrix वो transform होके A inverse बन जाने वाला है, वो transform होके A inverse बन जाने वाला है. So this is basically we have to actually do it. Now how this actually happens? I will talk about. अगर मैं A को लिखता हूँ, तो I can write this A as, for example, अगर मेरे पास 3 है, तो I can write 3 as 1 into 3. Similarly, I can write this matrix A as identity matrix into A. Now if I change this transformation and make this as I, if I change this and apply transformation and make this as I, similar transformation on this particular thing, then I can change it and make it into A inverse, and then I can write this particular relation which is actually true relation. So that's what our motto will be in this particular question. Now let us see and apply this particular thing what I actually talked about. So if A dash I and I change it like 3 minus 1 2 and 2 0 minus 1 3 minus 5 and 0 over here dash 1 0 0 0 1 0 and 0 0 1 over here. Now if I actually apply some transformation, that is first transformation what I am applying, that is row 1 ko, we want to make here 1 over here. Okay, we want to make 1 over here, 0 0 over here, 0 0 over here. Okay, so our goal should be to make 1 over here. So what we do, I actually take the help of second row and subtracting the second row, so we get 1 over there. So in that particular doing so, I end up getting the result as 1 over here. Then I get minus 1, then I get minus 1 over here, then I get if I take and then I get this is as the same 2 3, and this will be basically 0 minus 5, this will be minus 1, this will be 0, and simultaneous application should be over here also. So these values will be 1, this will be minus 1, this will be 0, this is 0 1 0, and this will be 0 0 1. If I go on and solve this, okay, and again I apply another transformation, that is row 2 goes to row 2 minus 2 times of row 1, and row 3 goes to row 3 minus 3 times of row 1, then I end up getting a result as which is 1 over here, 0 over here and 0 over here, and I get this result as minus 1 and minus 1 over here. Here I will get 2 and here I will get minus 2, here I will get 1 and here I will get 3, and simultaneously if I perform this particular operation on this identity matrix also, so what I will end up getting, so this particular result will be basically 0 minus of 2, that is minus 2, Okay, and here I will get 1 minus 1 0, and this will be minus 2, and similarly minus 3 over here, similarly 3 over here, and 0 and 1 over here. Okay, now again what we try to generate over here, now I will try to generate 0 over here and 0 over here. I will try to generate 0 over here, I will try to generate 0 over here, I will try to generate 1 over here, I will try to generate 1 over here, and try to generate 1 over here. Okay, now that's what our motto is. Okay, now let us again apply some transformation that I want to apply some transformation, that is rho 2 goes to half times of rho 2. So if I doing so, this particular element will be what? How much? This particular element will be 1. If I change these elements and I write this particular element will be 1, and this particular element will be half, and similarly this element will be minus 1, this element will be 3 by 2. Okay, and this particular element will be minus 1, this particular element will be 3 by 2. Again now I again apply another step, that is R1 goes to R1 plus R2. Now in doing so, what I get, R1 goes to R1 plus R2, this particular element will be 0, this particular element will be again will be minus 1 by 2. Okay, so let me write and change this and write this 0 over here, 1 over here, and similarly I again also apply, that is R3 goes to R3 plus 2 times of R2. So in doing so I will get 0 over here also. Okay, so I get 0, I get minus 1 by 2, I get 1 by 2, and I get 4 over here, and similar operation on this particular matrix, then I get 0, 1 by 2, 0, minus 1, 3 by 2, 0, minus 5, minus 6, and 1 over here. Okay, now these questions are actually very lengthy, that's why they are actually asked in CBSE examinations of like 4 mark question or 5 marks questions. Okay, now again I apply rho 3 को 1 by 4 times of rho 3 कर लेते हैं, तो this particular element will be 1, this particular element will be how much, this particular element will be 1, and similarly this particular element will be 5 minus 5 by 4 minus 6 by 4, and this will be minus 1 by 4. Okay, now again we have to make 0 over here and 0 over here. What I can do, I can add this particular, or without adding I can do rho 1 goes to rho 1 plus half times of rho 3, and similarly rho 2 goes to rho 2 minus half times of rho 3. I apply this transformation, rho 1 goes to half times of rho 3, and rho 2 goes to rho 2 minus half times 1 by 2 times of rho 3. Now in doing so I will get the results over here. In doing so I will get the result here as 0, and here also as 0, and here I will get 0, and here also 0, and similarly in doing so I will get these elements as, these elements will be okay, now these elements will become, this particular elements will become minus 1 by 8, and this particular element will become 1 by 8. Okay, so in this way, in this fashion, what we see over here, that the matrix A actually got changed to identity matrix, and this particular the identity matrix got changed to another new matrix which is actually known as the A inverse. So in this fashion you can actually calculate the inverse of a matrix. Okay, so I hope this particular result was clear. Okay, now let's move further and study about the properties of inverse. Okay, let us move further and study about the properties of inverse. Okay. Okay, now let us study about the properties of inverse. Now very first property, every invertible matrix possesses a unique inverse. Okay, every A inverse is basically a unique. Every A inverse is basically unique. Okay, now corresponding to any square matrix, okay, there is, if it is a non-singular, then there will be a A inverse, the inverse of a matrix will be exist, and that particular inverse is always a unique inverse. Okay, that particular matrix is always unique, always unique. Now next is known as the reversal law that we already studied, the seen in case of adjoint, also seen in case of transpose. The same thing applies over here, that is if I take product of A into B into C and so on, and then I take the inverse, now this particular result will be nothing but that particular so on into C inverse, B inverse, A inverse at the end. Okay, so this can also be written as like AB का whole का inverse is basically equal to B inverse into A inverse, and similar thing can be approached from here if this particular thing is given. Okay, I hope this particular thing is clear. Now next, third property that we study about, if A is an invertible square matrix, okay, then A transpose is also invertible. अगर A invertible, that is A का जो determinant का value है that is non-zero, then A transpose का भी value non-zero होगा. So then we can say that A transpose is also invertible, and A transpose का inverse is basically equal to A inverse का transpose. Okay. Now let us study the fourth property that says that if there is a invertible matrix, okay, if A is an invertible matrix, that means the A का जो determinant का value that is non-zero, then I can write adjoint of A का whole का inverse is equal to adjoint of A inverse which is equal to a matrix A divided by determinant of A. Now this is another very important result which should be remembered for problem solving purpose. Okay, now a बहुत important result है. You can actually get to the derivation of the results by trying on the king property. If you want me to actually solve and check that proof, you can comment me in this comment section. Okay, now let us move further and study how to actually solve some important questions. I hope the concept of inverse and adjoint was clear, and let us solve some questions now. Okay, now what is actually talked about in this question? Now in this question we say that there is a matrix given in form of some unknown quantities. Okay, now उसका जो adjoint है ना, that is matrix A. Sorry, the matrix A का adjoint is B. So it says the B is equal to adjoint of A. Okay, and what we are given with the determinant of A. So what we try to do, we try to calculate the determinant of B, which is basically equal to adjoint of A का determinant, and this will basically nothing the determinant of A to the power n minus 1, and this thing I can write as 2 to the power n minus 1, n is of 3, so 2 to the power 2, that is basically 4, so determinant of B is basically equal to 4. Now if I solve this particular determinant, that is 1, 1, alpha over here, 3, 2 and alpha over here, and alpha, 3 and 4 over here, इसका determinant value that is 4. Now if I apply some transformations and simplify the results, if I can simplify the result, it will be wonderful. Okay, I guess transformation उतना helpful नहीं होगा. अगर आप directly question को solve करोगे तो भी कोई दिक्कत नहीं होने वाला, ठीक है. So if I directly go on and approach the result, so along the first row I am expanding this determinant value, then I get up what the result is, that is 8 minus 3 alpha minus 3 times of this will be 4 minus 3 alpha, okay, plus alpha times of alpha minus 2 alpha, that is equal to 4. Now from here I get results as 8 minus 3 alpha minus of this will be basically minus 12 plus 9 alpha, plus this will be minus of alpha, this will be basically minus alpha square. This will be how much? This will be minus alpha square. This will be minus alpha square which is equal to 4. This will be minus alpha square which is equal to 4. Now if I solve this result, that is alpha square. Okay, now from here this will be minus of 6 alpha. This will be minus of 6 alpha. From here minus 12 and plus 8, that is minus 4, but we are taking negative of that, so it will be plus of 4. So plus of 4 is equal to minus of 4. From here alpha square minus 6 alpha plus 8 is equal to 0. Now what I can see, I can factorize at alpha minus 4 and alpha minus 2, okay, which is equal to 0. So from here I get the value of alpha is 2 and alpha is 4. Now what we are given in the question, we also mentioned with a condition that alpha का जो value है ना वो 2 से बड़ा है. So from here I only get the value of alpha as 4. Okay, now if I commute this particular matrix multiplication that is given in the question as, this is given as alpha minus 2 alpha and alpha minus 2 alpha and alpha, and b is given as 1 1 alpha is basically 4, this is basically 3 2 and alpha is 4, and alpha 3 and 4, so 4 3 and 4, and this is alpha, and alpha is basically 4, alpha is 4, and this multiplied into a column vector alpha minus same thing in form of a S transpose. Okay, so this is 4 minus 8, this is 4, and if I change alpha with 4 here and here over here, so I will get the result as 4 minus 8 and 4 over here. Now if I multiply, what I will get is as, if I multiply and get the result as 4 minus 24 plus 16, that is 4 plus 16, that is 20, minus 24, that is minus of 4. This is actually of 1 cross 3 and this is 3 cross 3, So the result will be of 1 cross 3 matrix. So this will be minus 4 over here, and similarly if I multiply this with the second row, I will get 4 minus 16. 4 minus 16 is basically minus 12 plus 12, that is basically 0 over here. And if I again multiply this with this 16 minus 32, that is minus 16 plus 16, that is 0 over here. And then I can multiply these three elements, I will end up getting the result as minus 16. That is a matrix of 1 cross 1. Okay, 1 cross 1 matrix, that is minus 16. Okay, so the answer will be basically minus 16. Okay, which is given in option number B. I hope this solution was clear. Okay, now let us move further and solve this particular question. Now this question can also be actually solved with the help of Cayley-Hamilton theorem that I actually have talked about in my shorts videos. If you are not following my short videos, then you are missing out on some short tricks and tricks to solve the important examination question base. Okay, if you want to know what the shorts are, go check out in the description box. You will find the playlist link of the short videos, and go check out on the shorts to save time in calculations. Okay, now if I actually solve in terms of getting the A inverse, the matrix A is given us as 1, 5, lambda and 10, and if I take the inverse of this particular matrix, I can write the inverse. Now inverse is basically nothing but determinant of A से divide कर दो और adjoint लिख दो, and we know shortcut for writing adjoint in a 2 cross 2 matrix. ना अगर मैं determinant से divide करूँ, determinant value will be 10 minus 5 lambda, और इसको मैं शॉर्टकट जानता हूँ कि आप डायगोनल एलिमेंट्स को रिप्लेस कर दो, चेंज कर दो, एंड जो नॉन डायगोनल उसको नेगेटिव से रिप्लेस कर दो. सो आई गेट द इनवर्स एज दिस. Okay, now if I get inverse as this, which is equal to alpha times of A plus beta times of identity matrix, where alpha and beta जो summation है, that is equal to minus of 2. Now from here I have to actually calculate this particular value. Now if I solve these results, okay, now let us check on and try to solve this particular result. Okay, so actually we see that these particular results get little bit tougher to solve. Okay, get little bit tough. Okay, but still we can solve it in terms of dual equation. So what we try to do, we in spite of solving in this way, we actually apply the Cayley-Hamilton theorem to get to the result quickly. Okay, that is 1 minus lambda 5 over here, 10 of this is lambda over here. So I will replace this element with some another quantity, that is x, maybe x, but eigenvalues are x. Okay, so lambda over here, and then I will get 10 minus that x over here, and इसका डिटर्मिनेंट अगर 0 करते हैं, then we get the result as 1 minus x into 10 minus x, okay, minus of 5 lambda is basically equal to 0. Now from here I can write the relation as 10 minus 10x, and this will be minus of x, that is minus of 11x plus x square minus of 5 lambda is equal to 0. Now from here I can also write the relation as a square minus 11 times of a, okay, and plus 10 minus 5 lambda times of identity matrix is basically equal to null matrix. Now if I multiply with A inverse, I will get A minus 11 times of identity matrix is basically plus 10 minus 5 times of lambda into A inverse, which is equal to null matrix. Now if I have to calculate A inverse is basically equal to 5 lambda minus 10 times of A minus 11 times of identity matrix. Now if I compare this result, that is A inverse is equal to alpha times of A plus beta times of identity matrix. So from here I can compare and get the result as 1 by 5 lambda minus 10 into determine a matrix A minus 11 by, this is minus, okay, this is minus of 5 lambda 11 by 5 lambda by 10 into identity matrix. Okay, now from here I compare and get the result. This result is basically alpha, and this result is basically equal to beta. Now from again I am given a condition, that is alpha plus beta is basically equal to minus 2. Now from here if I solve this and I get the result as 5 lambda minus 10, and ऊपर में आने वाला minus 10 is equal to minus 2. So if I solve this is basically equal to 5 lambda minus 10 is equal to 5. So from here lambda का वैल्यू कितना आएगा, 1. So from here lambda का वैल्यू कितना आने वाला है, so from here what I will get, the value of lambda by solving is equal to 1. ठीक है, it's not equal to 1, sorry, it is equal to 3. I did a calculation mistake over here. Okay, this is actually minus 10, so 10 उधर चलेगा, तो lambda का वैल्यू कितना आने वाला है, lambda का वैल्यू 3 आ जाएगा, because 5 lambda is equal to 15, so lambda value 3. अगर लैम्डा का वैल्यू 3 आ गया तो अल्फा का वैल्यू कितना होने वाला है, अल्फा का वैल्यू इज बेसिकली इक्वल टू दैट इज 15 1/5 एंड बीटा का वैल्यू कितना होने वाला है, -11/5. Okay, so from here if I compute whatever it is given in the question, that is 4 alpha square plus beta square plus lambda square is basically lambda का वैल्यू कितना है 3, that is 9, 3 का स्क्वायर 9, 4 alpha square basically 4 into alpha का वैल्यू 1/5 that is 1/25 plus 11 square that is 121 by 5 square, and this will be coming out as 9 plus 125 by 25. This value will basically come out as 14. Now if I solve this value will basically come out as 14. From here the answer to this question will be option number D. Now this is very important question, and this is very important question. Okay, now this question cannot be directly easily solved, get to the result, if we try to apply this particular common method. Okay, अगर मैं adjoint निकाल के मैं मेथड से करने जाऊँ तो we won't be directly getting the result, or the calculation will be tedious. In spite of that, I use this Cayley-Hamilton theorem to get to the result very quickly. I hope this particular solution is clear. Now let us move to the last question of today's lecture. Okay, so what this question talks about. Now this question जो type है ना ये काफ़ी बार repeat होता है, ठीक है, ये भी question काफ़ी type repeat होता है, ठीक है. Now this question is basically taken from JEE Mains 2019 question only. Okay, now let us see and try to understand what this particular products or continued product implies. Now if I product this first two matrices from this 1, 2 and 1 over here, so what I see, this is a triangular matrix, and in case of triangular product we don't have to actually take care of this particular lower element. So what we see, the diagonal element remain the same. The only element which changes is basically this comes as 2 plus 1, this element changes. Okay, this particular position element changes as 2 plus 1, and similarly if I go on multiplying with another matrix, that is 1 3 0 and 1 0. Okay, and if I compute this multiplication, what I see over here, this particular this lower triangular elements remains unchanged. Okay, now what actually changed, if you can see also the lower triangular element doesn't get changes. So what changes is basically this particular thing, that is 3 plus 2 plus 1, and similarly if you go on and performing the results, you will get from here, you will also get 1 4 plus 3 plus 2 plus 1. Okay, now if you commute and go on and commute the result which is given in the question till n minus 1, so what you will get, the final product will basically equal to 1 over here. Here it will be n minus 1 plus n minus 2, and ऐसे करते करते प्लस करेंगे 1 तक, 0 and 1 over here, and which is equal to given the result as given as 1 0 78 and 1. Now from here if I compare and calculate this sum, that is 1 plus 2 plus up to n minus 1, which is equal to basically equal to, now before talking about the sum we will actually remember one formula, that is the summation formula. Okay, 1 plus up to n, if I sum all this number, but all these numbers are natural number, we get the relation as n into n plus 1 divided by 2. Similarly if I apply this particular formula over here, this will be basically n minus 1 into n, because the last quantity or the number of terms is basically n minus 1. So this is n minus 1 into n divided by 2, this is equal to 78. So from here if I solve this n square, this is n square. Okay, let me check for pages. So this will be basically n square minus n minus of, this will be basically 156, which is equal to 0. Now from here I can solve this particular equation, that is n square minus n minus 156 is equal to 0. Now if I try to factorize this 156, so if I factorize this 156, that is 52, and what I see 13 4 ja. Okay, so what I see 12 and 13 is basically the relation. Okay, so in this fashion I can factorize this particular quadratic equation. So from here I will get the value of n as 13 or minus 12. Now what I see from the question, the question says, questions में जो बोला है ना, we already know before solving this any summation, that is 1 plus 2 plus 3, अगर मैं number of terms को अगर n minus n तक हो, and this particular summation is basically n into n plus 1 by 2, मैं तभी कर सकता हूँ when all the summation are given in continued fashion and these values are actually natural number. So minus 12 natural number है? No, it is not a natural number. So we will reject this particular value. So what we will get, the जो value है, that is जो मैट्रिक्स का इन्वर्स निकालने बोला ना, let us represent that particular matrix by A, that is 1 13 0 1 over here, and if I have to perform the inverse of this particular matrix, if I take firstly calculate the determinant का value है 1 which is non-zero, so we can calculate the inverse and the inverse will be exist. Okay, now if I calculate the inverse of this particular determinant, this matrix, this will basically 1 by determinant of A, that is 1 into adjoint of A, and in case of 2 cross 2 matrix, we have already seen that how to calculate the adjoint. We basically replace the diagonal elements and negative times the non-diagonal elements. So in this fashion, I get to the A inverse as 1 as matrix as 1 0 and minus 13 and 1 over here. So in this fashion, the answer will be 1 0 minus 13 and 1 over here. So this is how we get to the result, and the answer is option number C. Okay, so this is the answer. This question is a very important question, and how we actually approach this particular product rule. Okay, so I hope these particular solutions are clear, and with this we come to the end of the lecture. Okay, I hope today's lectures was clear among all of you. Okay, if not clear, please go through the video once again. So today's lecture goal, which was there, is actually done. Okay, we actually covered this all things. So I hope this particular lecture is clear, and with this we come to the end of the important topic of adjoint and inverse of a matrix. So I hope you have understood the concept well, and you will able to apply this particular concept in the upcoming calculation. Okay, the description box में chapter questions में मिल जाएगा, ठीक है. Today I'm going to be uploading the chapter practice problems questions, okay, so that you can apply them in your calculations. Okay, with this I come to the end of the lecture. Thank you.